Now let's look at example 4. The cost of a global data plan costs $60 a month for the first 10 gigabytes and $20 a month for each additional 1 gigabyte of data. Draw a graph of the cost, C, in dollars as a function of the number of gigabytes X used per month. So we're going to let C of X equal the cost per X gigabytes of data. So I've already gotten my table, my grid ready over here and started labeling things, and I decided I was going to need the full amount to get all the way out to 10 at least, and I need to go a little beyond that. And then I use 10 for each line going up. So when we work this out, we're going to find that our first 10 gigabytes, that means starting where X is starting at 0 and going from 0 all the way up to 10, we could be less than or equal to 0, we could be less than or equal to 10. I'm sorry, we have to be greater than or equal to 0, but less than or equal to 10, and we're going to find that that's going to cost us $60 a month. Now, if we use 11 gigabytes of data, then it's going to cost us, so anything over 10, not at 10, but over 10, up until we get to 11, is going to cost us an extra $20 for that extra 1 gigabyte. So we're going to pay the 60 plus 20 more, we will pay $80 for that one. Now if anything slightly over 11 all the way up until we get to 12 means we will have used 2 extra gigabytes. So we'll be using another extra gigabyte, so that'll be $100 at that point. If we go one more, a little bit over 12, anywhere between a little bit over 12 and all the way up to 13 gigabytes, we'll be paying for a third extra gigabyte. So 3 times 20, that'd be $60 on top of our 60. 60 plus 60, that'd be $120 if we're anywhere between 12 and 13, including 13. So we're going to continue following this pattern, but we're certainly not going to graph it until we get to eternity, because some of y'all can use a lot of data. So we'll just show what it looks like for this piece of the graph. And so at 10, or anywhere from 0 all the way up to 10, it's going to cost us $60. So starting here, we're using $60 all the way up until and including when we're at 10 gigabytes. From that point, if we use slightly over 10, so we'll go to $80 all the way up until we get to 11 gigabytes. From there, it'll jump another $20, and if we use slightly more than 11 until we get to 12 gigabytes, then it's going to cost us $100. And then we'll jump another 20 from here. And so if we're using from 12 up to 13, that'll cost us $120. Slightly over 12 up to 13. And so as you notice, it's like we're moving along smoothly, but then all of a sudden we have to start taking steps to go up. And hence this one would be known as a as a step function. So now how can we tell if we've got a graph of a function? How can we tell if that function is if that graph is going to represent a function? Because just because we have a graph doesn't mean it's going to represent a function. We can use what's called the vertical line test to tell if a graph represents a function. And a graph in the coordinate plane is the graph of a function if and only if there is no vertical line that intersects the curve more than once. Put another way, if you can draw a vertical line that crosses the graph more than once, then that graph is not a function. So when we look at the two examples at the bottom, we find that this graph over here would be a function, because anywhere that we would choose to put a vertical line, we are only going to intersect this graph one time. This one over here, on the other hand, so this one is a function. The graph on the right, however, there's a lot of places where we could draw a vertical line, and we're going to intersect the graph in more than one place. And so this one would not be a function because it fails the vertical line test. Here's our vertical line that intersected that graph twice. Let's see if we can do the examples on example 5. And so of the following graphs, which represent functions? So let's think about making a vertical line through this graph over here. Anywhere I choose to draw one, I am only going to intersect that function one time. And so that one is a function. How about over here? Is this one going to be a function? Well, it doesn't matter where I draw my vertical line. I'm only going to intersect this one time. And so this one also, B also, represents a function. How about down here on C? Now, we can pick a lot of different places where we can draw a vertical line, and we're going to touch that more than once. Now, if I draw a vertical line out here, I'm not touching it at all, but what we're looking for is places that would violate the rule. Like here in the middle, I'm only going to touch it once, but we're not looking for where it works. We're looking to see if it doesn't work at any place. And here it doesn't work because it intersects it twice, and so this one on C is not a function. Let's look over at D. Let's see if we can draw a vertical line anywhere that's going to touch this graph more than once, and we did right here. Even this vertical line known as the y-axis is going to intersect it more than once, isn't it? There and there. But it doesn't matter. Just when you're working a test, go ahead and draw, or when you're working, if you were working a problem like this on a test, you would want to draw a vertical line through there and show that it intersected it more than once, and then that would be why you would claim that that one is not a function.